Okay, I'm going to be going over the solutions for the Unit 8 exam study guide. So in this video, we're going to be talking about all the things that are going to be on that study guide. So I'm going to go through this hopefully kind of quick to try to get all of the information in one video, but if I have to separate in two videos, just look for part 2, okay? So here, and you might need to pause because I'm going to go right through the directions. So we have a airplane that's at 70 degrees bearing, so that means that this angle here is 70 degrees and this angle here is 20 degrees. So what we're going to do is we need to find the components of this vector, and the components of the airplane, we're always going to use x equals the magnitude of our vector times the cosine of theta, and the magnitude of our vector times the sine of theta for our x and y. So A is going to be the magnitude of the vector, and the magnitude here is 450. So 450 times the cosine of 20 degrees. It's always the angle between the vector and the x-axis. Alright, so we're going to calculate that in our calculator, and we're going to get 422.86 and 153.9. Alright, so then I'll do it for the wind. I'll do the exact same thing. This time the wind is at a bearing of 135, so that means that this angle here is 135 degrees. I'll use a different color. So that means this angle here is 45 degrees. Remember here that we're going positive x, so we have a positive x and a negative y because it's down. So I'm going to make sure to include those when I put them in my component form here. So we're going to have 70 times the cosine of 45 degrees and negative 70 times the cosine of, times the sine of 45 degrees. And again, the reason it's negative here is because we have a negative y value. It's going down. Okay, so we're going to calculate those, and we're going to get 49.5 and negative 49.5. And we should know that know that they're both the same because it's 45-degree angle, and in the unit circle, 45-degree angle is always the same coordinates. All right, so now what we're going to do is, once we've got our vectors in component form, now it can be 1, it can be 2, 3, 4, 5. I can just keep adding to these vectors, and I'm just going to do the same work, and I'm going to add the x parts and the y parts and put it as a resultant. So my resultant vector is going to be the sum of these two. So 422.86 plus 49.5, which is going to be 472.4. Then 153.9 minus 49.4 is 104.4. And again, we're adding them, so when we add a negative, right, it makes it smaller. So now this is our resultant vector, and our resultant vector, which is the true bearing, if I plotted this, I would go 474, that would be out here, and positive 100, so it would be something like this. Right, that would be my vector. So I've got to find this angle here, which would help me find the bearing, and I have to find the magnitude. The magnitude is pretty easy to find. We're just going to take the square root of 472.4 squared plus 104.4 squared, so it's the square root of the x squared plus the y squared, and we're going to get 483.8 miles per hour. Okay, so this would be our true speed. And our bearing, we're going to find this angle theta, and we always use the inverse tangent of y over x. Okay, that comes out to be 12.5 degrees. But we want the bearing, so we really want this angle, so we're going to subtract from 90 degrees. And so our bearing is going to be 77.5 degrees. All right. So that's an application of vectors. Let's go to the next one. The next one was plotting polar coordinates. So we're going to plot 3 pi over 4, and pi over 4 is here, and then we're just going to go out 3. So 1, 2, 3. So there's point P. Point Q is negative 3, negative 2 pi over 3. So we're going to have to go negative 2 pi over 3. So 2 pi over 3 is right here. So if I went positive, I would be going this far. If I'm negative, I got to go the same amount. So the same amount would be this far negative, counterclockwise. Okay, so we're looking at this line right here. And we're going to go negative 3. So instead of going out 3 here, we're going to go back 3. 1, 2, 3. Okay, there's Q. R is pi over 3. So here's pi over 3. And negative 2, so we're going to go back 2. 1, 2. So there's R. And finally, we'll do S. S is negative 3 pi over 4. So where's 3 pi over 4? Is this far. So 3 pi over 4, we would go this far. Negative 3 pi over 4, we're going that far. We're going out 4. 1, 2, 3, 4. Okay, and there's S. All right, so that's plotting points. We're going to convert from polar to rectangular. So the conversion we're going to use is x equals r cosine theta and y equals r sine theta. And we can just plug in directly. And we're going to do this without a calculator here. So 3 times the cosine of pi over 2 and 3 times the sine of pi over 2. So the cosine of pi over 2, I got my unit circle here. The cosine of pi over 2 is 0. So this is going to be 0. The sine of pi over 2 is 1. 1 times 3 is 3. So my point is going to be 0, 3 in rectangular form. All right, let's look at this one. X equals negative 2 cosine of 5 pi over 6, and y equals negative 2 sine of 5 pi over 6. Well, where's 5 pi over? Here's 5 pi over 6. The cosine is negative root 3 over 2. All right, so that gives me root 3. The sine is 1/2, so negative 2 times 1/2, which is negative 1. So my point's going to be root 3, comma, negative 1. All right? Okay, let's look at converting from rectangular to polar. So this time we're going to use r squared equals x squared plus y squared. So r is the square root of negative root 3 squared minus plus negative 1 squared, which is the square root of negative root 3 squared is 3 plus 1, which is going to give me root 4, which is 2. So that's my r. To find my theta, I need to look where the tangent theta is the y over the x. Now my y here is negative 1 and my x is negative root 3. So to make this make sense in my unit circle, I have to have it in terms of coordinates in my unit circle. So to put that in coordinates in my unit circle, I put that as negative 1 over 2 over root 3 over 2. Again, these are the coordinates in our unit circle, and if I simplified this, I would get negative 1 over negative root 3. And if you watch my video on using inverses in the unit circle, then this should you should remember when we did this. So we're going to look for the y coordinate of negative 1/2 and the x coordinate of negative root 3 over 2. So my y coordinate of negative 1/2 and my x coordinate of negative root 3 over 2 is right here at 7 pi over 6. So my corresponding polar form is going to be 2 comma 7 pi over 6. And you could have written it in, you could have written also as 210 degrees. It would also be okay if you wrote it as -2 comma pi over 6, because your point is going to be down here, which means you could have gone this direction and then gone back 2 units, or yeah, 2 units. Okay, so that's rectangular to polar. My pen is going crazy on me right here. Let's go ahead and graph each of the following polar equations using the table of values. So I just noticed I got about 5 minutes left on this video before it cuts me off, so I'm going to go ahead and do this one problem, and then I'll go on and do a part 2. So for this, I'm going to make a table of values, R, theta and R. And my theta values, since I know this is not a rows, I'm just going to go ahead and use 0, pi over 2, pi, 3 pi over 2, and 2 pi. I'm going to plug in my value here, and I'm going to get cosine of 0. Cosine of 0 is 1, so I'm going to get -1. Pi over 2 is going to give me 0. 1 minus 0 is 1. Pi is going to give me -1, which is going to give me 3 here. Negative 3 pi over 2 is 0. It's going to give me 1 again. And 2 pi is the same as there is -1. So I'm going to go and plot the points. 0, -1. 0 radians, -1 back here. And then pi over 2 and 1 is right here. And pi and 3 is right here. 3 pi over 2 and 1 is right here. And then 2 pi -1 is right here again. Now, this is going to be a limacon, and I know that because of the way it looks in its equation. But since I have this thing out here, it's probably going to do some sort of loop. So I'm probably missing something here. And I think if I used pi over 3, pi over 3 in here, I would see that I would get 1 minus 2 times the cosine of pi over 3. And the cosine of pi over 3 is 1/2, so I get 1 minus 2 times 1/2, which is 1 minus 1, which is 0. So I'd actually have 0 in here. So it goes from -1 to 0. So it goes like this. Oh, there's where, see, we can see our loop in here now. I think I might have done, oh, I did this one wrong here. It should be on the other side. Okay, 1, 2, 3. All right, that makes much more sense. All right, so it's going to loop in like this, come around, come out here, right here, right here. Okay, so this is a limacon with an inner loop, and you can see that by picking that value. So if you see something like this where it looks a little strange, and you know it should be a limacon, maybe pick an extra value. Okay, so I'm going to leave you at this video. Look at part 2 to get the rest of the study guide.